Is OBS going to behave today? Let's find out together. Twitch. 1, 2. 1, 2. All right, Twitch delay is real, but it does work. All right, today is November 12th, 2024, here at ASU. We're in CSE466, Computer System Security. So this is our third one-week module, right? How's the one-week pacing going? We're good? I mean, you guys kind of lucked out with that extension, but I think these are pretty easy modules. The numbers say these are pretty easy modules, so hopefully you guys are on board. So we just wrapped up 2 modules, despite the fact we were supposed to have one-week modules. The first was race conditions. One of my takes on race conditions was like, when in doubt, just fork more, have more processes. I don't know if this is just an old person reference or if this class will get it, but I dug it. That one actually got me laughing out loud. This here is the difference between what is LSTAT and STAT, right? Do we follow symlinks or not? That was one of kind of the sub problems in race conditions. Yeah, that's fair. We also had sandbox escapes. This was officially what was supposed to be going on. We just finished this week here. And the sandbox escapes is an interesting module, I think, because it starts off with like very simple things, right? Like we have a CH root jail. Can we just change the path? Can we dot our way up out of this thing? And then you start getting to like level 11, level 12, I think around level 9 maybe, where it's no longer about like, how do I actually escape the jail, but how do I communicate given a set of restrictions, right? And that's where you have to get a little bit more creative, and you have to be like, okay, well, maybe I can't write, maybe I can sleep. Can I communicate using a side channel or a different mechanism? This concept of side channels we saw all the way back in Rev with the Yan 85. We definitely touched on it here in sandboxing, and we're going to hit it very hard a week from now when we hit MicroArch, because that is entirely based on the concept of side chains. If instead of doing things automated by side channels, you're like doing stuff by hand and running things individually, that just sounds like pain. Discover the for loop. I don't know. Like this phenomenon exists across courses. It's not specific to this module or 466. This particular meme, I believe, was a joke, because I remember when it was posted. But we do see that in like there's a Rev challenge where it asks you to like leak a value in memory all the way back in like 365 for GDB scripting. You're supposed to GDB script it so it just like spits out this value that's on the stack. And people in it originally was like, do it 8 times. That class would do it by hand 8 times. So then we like, okay, 20. Surely no one will do it 20 times. You know what happened the next semester? Someone did it by hand 20 times. So then we increase it again and again until now it's just like some insane number. And I'm sure there's still someone who sat there for hours doing this by hand. I don't know, right? If you're in computer science, like hopefully you're learning how to use a computer to solve problems. And that is not just like the immediate assignment that you're tasked with, but whatever problem is in front of you, right? The field of computer science is about abstraction and problem solving, and it is just abstraction built on top of abstraction. And if you're good at computer science and you've worked in this field and programmed for a while, while you're trying to program or like solve a problem, reason about something, you'll write code that is a tool. You'll write your own tool on the spot to solve what you're trying to solve because you start thinking in these high level abstractions, and that's how you function. That's how you end up becoming a terminal junkie, right? So yeah, sandboxing, it's really kind of about being clever and creating these side channels. And I did see that a lot of people had some fun trying to write faster and faster solutions or more creative solutions, which is always kind of fun. I really enjoy the sandboxing module, despite it not being particularly difficult. For whatever reason, people kind of hung up on 13. 13, for those that don't remember, was the one that had a parent process and a child process, where the parent would fork off a child. The child was in the jail, and you had to communicate via a Unix socket. This is actually a very common pattern right? Of forking off some child, putting restrictions on the child to limit it, but still allowing it to communicate out to another service. You will see this a lot with services and operating systems. I think I rambled a bit about this in office hours, that there was on Hacker News, there was just like last week, there was an article that was posted or linked to from there about macOS sandbox escapes, and they leverage using a child process or your process that is in a sandbox. Most processes are in their own little sandbox in macOS. It's just kind of invisible to you. And the way that they were escaping the macOS sandbox was by communicating with these service processes that were just kind of running in the background in the periphery. And so by communicating with something that is outside of the sandbox, you may be able to leak or escape that sandbox. And so this idea of having a limited number of channels while you're in a jail and then exploiting those kind of external things that you can interact with is actually quite common. So I think it's a cool level, but it definitely was a little bit different than the prior ones. So I kind of get why people weren't necessarily on board with it. The sandboxing modules, once we got to the namespace stuff, it is kind of like I can't say this word, starts with an M. Anyone know it? Russian nesting dolls? It's M, Machi.
I thought it was babushka.
No, a babushka is like a grandmother, is my understanding.
Oh,
is it? No, there's a word that starts with an M that I can't pronounce. That is the correct word for what this is. These nesting dolls. You got it? Yeah, you see it, right? You're like, I can't say that either. Yeah, but yes, the levels do kind of end up in this problem when you have multiple terminals. Is the terminal on the host system? Is the terminal in the VM? Is the terminal in the namespace, right? And these things get nested. We are going to kind of have this same problem in the kernel module, and those that have started on it are definitely starting to think like that. One of the interesting things when it comes to Docker or mount namespaces is when you do mount something from a host system into a container, right? You are functionally root with access to that file system. It's one of the kind of common gotchas is if you have an unprivileged user on a system, which is quite common, that has access to the Docker daemon, you can create a container or launch a container and like mount root inside that container, at which point within the context of that container, you're root and you have access to the entire file system. And so any unprivileged user that has access to, yes, somebody types the word in the Twist chat, and I'm just going to choose to not embarrass myself by pronouncing it. But you are effectively root because you can mount the host file system inside the Docker container and then access or do whatever you want. And so that is an interesting meme there as well. On the lecture videos, I did not add new videos. So we got the classic Zardis videos. I have not seen these in a while, but I will just trust the memes. When Zardis says that we're at the point of extensive swearing, or he just begins swearing. It's a common gotcha with live demos, right? I love Jan demos. But Jan is a lot braver than me when it comes to his live demos. And so sometimes they go really off the rail. But you usually learn something along the way, right? Because he like tries to recover and explain where he's at. For Twitch, I see that you cannot see the top right text. It says a sandboxer, when they mount a directory they shouldn't have, and I use it to escape. For the sandboxing module, for the kind of namespace related challenges, there is a unintended solution that involves what this meme is referring to, right? None of the intended solutions for the sandboxing module involve the mount namespace, but it's been around to this point. It's kind of a classic, and so we haven't done anything to fix it, right? If you figured that out, all right, you cheesed it, but like you still learned about namespacing, right? Like the thing that you were doing to kind of get around it was using the concept that we want to teach. One of the gotchas for the very last level, if I remember right, was 18. you have to, somebody says no video. I did not release any new video for the sandboxing is what I was stating. I thought about it and then decided not to or ran out of time or something to that effect. Anyways, the challenge tells you that you can mount, I think, Home Hacker or something else. And for whatever reason, people just default immediately to the right. They're like, I put Home Hacker here. And then that is just a recipe for pain. It turns out you should probably pursue the path of something else. Although I don't think you can literally put proc in that level. It definitely is a happier path going down there. Okay, no, just Twitch. Yeah, I can't fix Twitch. All right, course schedule. So the weeks here are kind of a lie, but whatever, that's planned. We're currently on kernel security. That's going to wrap up here next week, Monday, and then we will end the semester with two-week modules. These two are definitely the two most difficult modules of the entire course. I don't know which is more difficult. So MicroArch is going to really kind of test your ability to think about side channels and not being able to debug anything. Like you have to have this ridiculous conceptual understanding. And then system exploitation, which is the final thing that we do, is kind of a cumulative module. And that's where everything that we've covered, except for MicroArch, is fair game. But you will be able to debug it. So, yeah, there's that. We had extensions, right? This was meant to help you, right? Like I really want you guys to succeed, but I can't save you from yourself. It's a consistent theme. It's one of the challenges of this course, not only for students, but for on the instructor side as well, is that this content builds upon itself. There's a lot of stuff to cover over the course of the semester. And while I'm happy to move due dates, when it makes sense, that the show must go on. And so what ends up happening when due dates and things get extended is things just pile up and pile up. And if you're the type of person that procrastinates, it definitely turns into a big mess at the end. So how'd we do? Well, there are two modules. We had race conditions. Race conditions was the one that ran for 2 weeks here. I would say everyone crushed it. Does anyone disagree? So it's a pretty biased graph there. Sandboxing. Okay. Not necessarily not as straight of a line, but it's pretty dang close. So people did pretty well overall there. Course grade. I actually generated this graph on accident and just decided I'd keep it in there. Because this is including the kernel module, which I recognize is not due, right? And so this is including like the kernel checkpoint. If you haven't hit it, yeah, you got 0. And if you haven't finished at 100% on kernel, yeah, whatever you got there is kernel. Now, this is actually the kind of distribution much closer to what I would strive for, right? Ideally, we would have a bell curve or a normal distribution that's centered somewhere around like 80, 85, right? Low, mid, B. Right? That would be a decent distribution for students. But, it turns out kernel's not over, so I can't get the curve that I want. And instead, you guys are like this. And so we're still on the left-hand side of a bell curve, where the average is right around 100%. One thing that is worth noting when you look at these numbers is because somebody has brought this up to me outside of class, is the total. What did we start with? Anyone know?
We started with equal left on left hand.
No. So this sums to somewhere around like 70.
Started with like 120 now.
Students? No, so initially when registered, we had about 160 students. Now, I'm only counting I'm only counting students on all of these, people who have solved the most recent thing, like have at least one solve. So there are students who are registered who are not on here. So like if you solved nothing of sandboxing, you would not be on this chart, right? You would have to have at least one solve to just exist in this data. I believe that's a fair line. So there are more students registered, but as far as who's actively playing the game, yeah, it's somewhere around like 50, 60, right? And that goes back to, what did I say at the beginning of the semester? I said 40 to 60% will not make it to the end. All right, we're right around there. All right, if you do the math, somewhere around 55, 60% didn't make it to the end. Just anecdotally interesting. So, MicroArch launches this Friday. It is a 2-week module, so that is hopefully a good thing. I mentioned this last week, Thursday. CSE466 Software Exploitation is a graduate level course that kind of follows up on this material for the spring semester. Right now, the course is already full. It like instantly filled, which is awesome. I'm going to look into possibly expanding the number of seats that are available up to whatever the room capacity is. It's typically what we're allowed to do, because I don't believe we're there right now. In general, historically, because this will be like the third or fourth time that this, I think third, maybe fourth. I don't know how many times it's been taught, but historically, every time that it has been taught, the week 1 drop rate is like 90%, because people don't necessarily realize what they're getting themselves into. Very similar to this course, where I had the first couple weeks where I was like, this is going to be super spooky and scary, and please don't take this class if you want to, blah, 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 right? It has a very similar effect, except people actually listen and bail very quickly, because this is what you need to know slide is just ridiculous, because it's everything that you've learned here. But if you are still interested in it, and you have not registered and you're taking this class right now, let me know, and I'll see what we can do, or let you know when I find out room capacity's changed, etc. If we end up at a deadlock there, like I said, week 1 slots will open, because it always does. Okay, with that, what do you guys want to talk about on the kernel?
Shell coding.
Shell code. Okay.
Debugging the VM or
VM debug.
yeah.
All right, debugging the kernel. All right, and I brought some canned ioctl stuff that we can run through as well.
If we have time, can we talk about SecCom? But I know it's so relevant.
So I was following that conversation, and generally speaking, if people are having productive conversations, I don't hop in, right? It's just like, yeah, I'll let you guys figure it out. Like you're on the right track. One of the things that is I'm not gonna say problem, but is a challenge teaching this, is if you don't understand what the kernel is, right? Hopefully, does everyone here have some concept of what a kernel is? Yeah? So if I'm SSH, who am I? Hacker at pwn.college. Talk about slabs. You know, at this point, I'm not sure you help that much anymore. You just troll me. Okay. I'm currently the hacker user, right? If I sudo su, I'm the root user. Am I the most powerful thing on this system? No. What is the most powerful thing on this system?
Kernel.
Why?
Because kernel is the thing that gives permissions for root user every user, and it has access to it.
Okay. So according to the rules in userland, root is the most powerful user, right? But I showed last week when we were talking about sandboxing, and I mentioned capabilities, right? I was able to be a root user and be denied something, right? Who denied me?
Kernel.
The kernel. One of the questions was setcomp, right? How does setcomp and the kernel relate? Now, I mentioned this on the Discord. Let's see if technology wants to work on the fly. Technology does not want to work on the fly. Okay. What can we do here? How, like, if you were to implement setcomp, how do you think it would work?
When a program calls a syscall, makes a syscall, the syscall interrupt handler handles that and calls a relevant syscall based on RAX. So before that call is made, we can just check if the RAX value is among the prohibited syscall values.
Okay, so if I understood correctly, because I was only like halfway listening, I'm still wishing the iPad behaved as it should. But you know, such is life, doing live demos.
Praying to technology.
Yes. Well, what we have here is we're in userland, and then there is the kernel. And in userland, we want to do something, right? Oh, I should just use the tab key. That is the superior key. All right, so we perform a syscall here. Yeah? What happens? So what happens after we perform the syscall?
An interrupt is raised. I mean, syscall raises an interrupt, and the interrupt's ISR sees that it's a syscall and checks the RAX value to see which syscall method to call in the kernel.
So I have this line here, right? It says userland, and then it says kernel. Well, when do I cross this line?
I don't get it.
So you're over here saying that I do this syscall, there's an interrupt.
Yes.
Who handles the interrupt?
The ISR in kernel.
Okay, so this probably a nicer way of phrasing it. Boom. There's something like this, right? We perform the syscall in userland, and that switches our context over into the kernel. Okay. So then how does setcomp fit into this?
So the ISR, before calling the relevant syscall method like chmod or open or close, it checks the RAX value to see if we are trying to call a prohibited syscall, and if we are, it raises another.
Okay. So inside the kernel, we're going to check RAX. And if RAX is a forbidden number, right, per syscall,
We send a signal.
then we're going to, what is it, SIG-sys. Otherwise,
Call the method, call the syscall method.
call the kernel's internal method. All right. And then once we've called that method inside of the kernel, what happens?
That's how far I got.
Okay. Now the answer is we put the answer in RAX and we jump back over to userland, right? And that's why when we like call open, we get a file descriptor in RAX, right? It's very similar to calling a function in userland, right? Except the way that we're going over there is with this syscall instruction. Now, if I have shellcode, and this was one of the discussion points, somehow, if I'm already over here, and I'm executing shellcode, what was my question?
Does setcomp come into play?
Oh yes, that was my question. You followed my train of thought. It fell out of my head. Does setcomp matter?
No.
No. because setcomp restricts what happens in user land. Setcomp does nothing to what goes on in the kernel. Now, Twitch here says, Twitch has -1 ring of the kernel. I'm not sure where we're going there. So generally speaking, when we talk about user land and the kernel, we do talk about rings though. What's a ring?
It's like the level of privilege the CPU allows to the process in a ring. Like userland is in ring 3, so userland can do some things because CPU prohibits it.
Okay. So you said ring 3.
Yes.
Okay. So it's architecture specific, right? No, not ring 2. It should be ring 0. Generally speaking, this is architecture specific, but it is a convention that exists. Now, there is an important word that you said there. You said it was enforced by the CPU, right? So if it's enforced by the CPU, is this something that I could overwrite as root?
No.
No, right? There is a bit in the CPU that says, what ring are we in? What mode are we in, right? What can or can't we do? And this ring determines more than just does setcomp matter. This ring actually can enable and disable assembly instructions, right? There are assembly instructions that you can only execute in
0.
Yes. Like for historical reasons, when a CPU, a lot of x86 64 CPUs boot up, they actually boot up in like a 16-bit mode, right? And then they load some stuff, and then they jump into a higher mode, and they jump into a higher mode until they get their way up to a 64-bit mode, and then they will step down. Now, why don't we use ring 1 or 2? Like, what are those for?
I read those are historically for device drivers, but Linux took a different direction for device drivers, so they are not.
Yeah. So historically, the intention was for these kind of middle tiers between the kernel and user land to be used for things like device drivers. In practice, that was found to be kind of a lame idea because it turns out you don't want kernel device drivers messing about with things, because kernel drivers are like unverified code from the perspective of the kernel. And because of that, you remember the blue screen of death on Windows, right? A lot of that had to do with like kernel drivers.
But isn't putting Windows kernel drivers in ring 0 even more dangerous? Because I mean, ring 1 and ring 2 should have more restrictions than 0, right?
The statement was, isn't it more dangerous to put kernel drivers in ring 0? Well, yes, but like the way that the kernel works is like we try and keep everything that we reasonably can out of ring 0, right? It turns out you can do most things that you need to do on a computer from ring 3 and then interact with ring 0 via some protocol that's defined elsewhere, right? Such as syscalls to interact. Like you don't need to be in ring 0. Okay, so starting on, I think it's level 4. I just want to make sure we had a little bit of background there. I think it's level 4.
The first ioctal.
Yeah, the ioctal. All right. Historically, these first couple levels don't involve ioctals, so I'm going to skip them. But we can still use this as a kind of stand-in for reasoning about these challenges. Somebody says it makes sense setcomp only affects user land because if the kernel can't, for example, open, read, or write files, then it pretty much breaks everything. Right, when you call, and this is another relating to that conversation, because I wasn't sure exactly what you were doing, but if you are inside the kernel and you're trying to call write, what is the act of calling write? What is write? If I do man write, What man page? Well, that's not the man page I wanted. I'd have to go to man 2, right? What is right? What?
This is
A syscall.
Yeah.
What is a syscall? It's the thing where you go from user land to the kernel. What if I'm in the kernel? Can I go from the kernel to the kernel? No, right? Like there, and that's one of the problems that Jan describes in his videos about writing kernel shellcode, right? I don't know that that's what you were doing, right? Because that challenge has a number of pieces.
yeah.
And so that's totally fair. But if I'm already in the kernel, the syscall instruction is meaningless. Well, it's not meaningless. It'll just like cause problems and blow up, right? I can't call right from, I can't sys transition to the kernel from the kernel. And so the shellcode that we have to write is different. Okay, so just a getting started reasoning about these things. We take a look at the challenge directory. I have baby kernel level 4.ko. What is this? Did I just run it? Why? Why doesn't this work? It's a kernel module. So if I want to work on these kernel modules, we do need to start it up in a VM because we aren't going to let you load kernel modules into the host system of our infrastructure. That just sounds like a problem, right? So I'm going to run VM start. VM start is not anything like super crazy, all right? Some people seem to think this is magic. It is not. You can look at it. It's in ops, pwn.college VM. It's a Python script that's just calling other things, right? It's just making it pretty for you. And what you will see here, if I find it, if we grep for this is your VM. Your VM is just one process, right? It's a single process that's running a virtual machine. And these are all of the arguments to make that we have set up to make this thing behave. And so we're just saying, instead of typing out this really long command, you get VM start, VM connect, right? Now, when I run VM connect, that drops me into the shell or into the VM, and we see my prompt has changed. It's very important to know if you're in the VM or outside of the VM.
The VM connect went so fast.
So if you just type VM connect, then it has to start and then connect. You'll notice I typed start first and then like had this hand wavy thing. It's because I'm a magician and I know what's going on behind the scenes. Right? The act of connecting is actually quite quick. But if you just type VM connect, it has to start and connect. Okay, so now I'm inside the VM. How do I know that this kernel module is loaded? Okay, someone says D message. Is there anything else I can type? I think this is a command, right? So list modules. There is a challenge module installed inside the VM. And then the other command that people said was dmessage, which dmessage gives you all of kind of the kernel's print information, right? Inside the kernel, there's an equivalent command to like print or puts. It's called print K. You can see what comes out of there right here. And so when the kernel module loaded, it gave us this nice little help text. Okay. So the first thing you want to try and do on these challenges is reason about what the heck is this thing, right? Because we don't have a lot to go off of. And while you could use GDB, and I love GDB, the correct tool here is to use a decompiler. So we'll fire this up. I mash tab. We let I to go. We got a whole bunch of crazy stuff going on there in Twitch. I don't know, man. There's head grabs and dancing aliens, and it's too much for me. Okay, so where's main?
Init module. I mean,
You say that's main?
There is no main.
There is no main. Well, how does this thing run?
Init module.
Okay, so kernel modules don't have an entry point, right? And that makes sense because you don't like start a kernel module. There's a number of functions that get triggered at different points. So what you're really doing is, or looking at here, are various functions that are executed when this module is interacted with, right? There are different ways that you can interact with this kernel module. The first thing, interaction point that we care about is a init module. And here we see a bunch of print statements that say that exact same thing, right? Good luck, blah, 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 welcome to the module. That's chilling right here inside of a init module. That's what all of these print statements are. We see this kernel module, blah, blah, blah. All right, not super interesting. So how do I interact with this thing?
Device.
What else do I want to look at?
Device underscore things.
Device underscore things. So for this module, this is true. All right, the statement was device underscore thing. It turns out, though, these do not have to be named this way, right? I could have named this function, or not I, because I didn't compile this, but somebody could have called this Fred, right? And the Fred function could get called when you open something. There is a way to register what function corresponds to what action, right? This naming is really just to make it easier for you. But if you're...
Is there a default way that it assumes, or do we just have to give that mapping every time? Like, is there a convention like?
Is there a convention?
Yeah, like.
I'm not going to answer that just because I'm not sure and I don't want to authoritatively say yes or no. I know that because I have written kernel modules that have insane things. I know how to link them, right? So say this function gets called on open, but I'm unaware of the convention because I don't follow the rules, right? I'm the guy that says warnings or suggestions. So do you really think I know what the correct way of doing something is? I know what works. Okay, so we have this device open. This is what's triggered when we open this kernel module. And it says it's going to print, it looks like device open, inode equals something, file equals something, right? How do I trigger this?
Guys, interacting with that pwn.college file.
Yes. So inside of the init module, there was this proc create. This is exposing a kernel device at proc. And if we're inside the VM here and we take a look at proc, we should see that there is this pwn.college pwn.college device. It doesn't exist. It's empty.
It's a Python component.
Okay. So I can call open on it. I can... there's not a whole lot else going on here, is there? Just ioctl. All right. Does anyone want to tell me what ioctl is or how I can find out what ioctl is? There we go. See? You guys don't sound enthusiastic about it anymore, but you certainly know it. All right, well, we read the main page. ioctl is one of those Swiss Army knife functions. I talked a little bit about off stream on Thursday because it was part of my super fast race. I was using ioctls. ioctl is like this Swiss Army knife generic function where you give it a file descriptor, you give it some number, and that number means whatever the thing wants, right? There is no standard there. And then you provide a variable number of arguments that again mean whatever they want. So this isn't a very useful man page, right? I mean, it tells us just that it's like the Swiss Army knife thing. It exists from a time when things were a lot more fast and loose, but it's still used all the time. And so if I want to trigger or interact with this kernel module via ioctl, we see that it takes a command and then IDA thinks an in64 arg. IDA could be right, IDA could be wrong. So some people probably did this. How am I on time? Okay. A lot of people probably did this in C, and they wrote something like this. Could write it by hand, but we'll look at it here. So what I'm going to do is I'm going to open proc pwn.college. I'm going to open it read-only. It doesn't really matter. I just need to have a valid file descriptor. I'm then going to call ioctl on that file descriptor. I'm going to give it 1337 and then the string hello world. Now, one thing that you can do, if you look at the man page for dmessage, there is -w for follow. This allows you to just track the output, if you can type, of dmessage. Watch what happens when I run my a.out. We get additional output. So now we see device open, device ioctl, device release. These are from that kernel module. Right? We see inside of device ioctl, there's this print k. What is this unknown? This is where it has that string, device ioctl, file equals whatever, command equals whatever. And that is what we see over here in the dmessage. And so now we can start to reason about, are we able to trigger code behavior here? And that's cool, right? Where we're in C. Now, one of the things that you also may want to try and do is write this in Python. And if you read the Python docs, you'll end up with something like this. I do not know how to make this work. I don't know anyone that knows how to make this work. If you know how to make this work, let me know. Because what's happening here is Python is, like many tools, trying to help us in ways that we do not understand. All right? What I mean when I say that is let's run this and let's see what dmessage output says over here. It's going to take a little bit longer. We're inside the VM now, firing up some Python. My command number is 21505. Why? I have no idea. Did I pass a string was the question. P64 will give me a byte string. Okay, and you're like, okay, Robert, you were trolling us. Give a real number. Yeah, is that what you think it is? Let's do it. That's still not going to work. It's still gonna give us command 21505, and I don't know why.
Oh, no, it gave on
What?
The issue is
What?
the issue with Python is that the arg value gets messed up. You can't pass a valid arg value.
Yeah. So in general, the reason that this is paying, I really didn't expect the 1337 work, but that's fine. The problem is this buff, right? For whatever reason, Python, there isn't a clean way, and there is something which I'm going to show, which is a reasonable way of doing this in Python. But when we do it like this and use this high-level F-control ioctl, it tries to do something fancy with the bytes and convert them into C types and some other nonsense, and it doesn't actually do what you think. And if you were to strace this, it actually calls ioctl like 3 times. And I don't know why. And so I would recommend to just avoid this because it is a path of pain that for like 3 years now, I do not know anyone that has gotten this type of code to work. Instead, I would recommend if you're going to write Python code, to use what I'm going to call a hybrid approach, but it's really not that crazy. We're going to just use C types, which is a super cool interop library for using calling into C libraries or dealing with C structs, right? And kind of defining these byte level things at a lower level where I don't have to deal with the higher level Python abstraction. And so we use C types to load this dynamically linked library of libc. And once we have this libc object, we can call libc.ioctl. I know what libc.ioctl does. It's going to call just a sane ioctl. It's going to be a really thin wrapper around the ioctl syscall. And that, I could give it F, I could give it F file number. In case you didn't know, like when you open something, you get this Python file. You can get a literal file descriptor from file number, but in this case, I believe it maps for you. We give it a number, we give it a buff. If we do that, this buff is going to be what we think it would be. We can give it a byte string, and things will behave as one expects. This is my suggestion for how you want to do things. In this module, you'll end up trying to use ioctl, and you'll need to define what this buffer is, right? We just call it buff. And when we looked at level 4 here, IDA thinks arg, which is equivalent to my buff, is an int64. Is it? No, it's really not. Like a better type of this thing. What's that?
It's a buffer. I mean, it's a
Point.
Yeah, it's some pointer. I'm going to call it a char star. It's some byte pointer, right? With this could be a pointer to a struct. This could be a pointer to an array. It could be a pointer to a string. It could be a pointer to whatever, right? It might as well be a void star because its meaning is going to be dependent upon what is happening inside that particular kernel module. Anyone want to tell me what this particular kernel module is doing?
Copy our argument to the kernel and then combine that with the string.
Cool. So the statement for Twitch it's taking that argument that we're passing. It's using this copy from user. What does copy from user do? Why does this exist? We have memcopy.
Copy to the kernel from what address, I believe, and other one is number of bytes.
Right. So the statement was a definition of what this function does. It's essentially a memcopy, destination, source, number of bytes. Almost every time data is moved from userland to the kernel, from the kernel to userland, you're going to see these functions being called. This is actually a security mechanism to ensure that we aren't doing strange overflowy things and that pointers point to where they should. They're in the correct general region of memory. You don't need to know that for this module, but I think it's worth mentioning. We do cover what's going on there in 598. So it checks for this command value, and then it just does a string compare on whatever bytes are pointing to. I'm not going to solve it, but I hope that you can. Now, later modules, or later challenges in this module, will not be as straightforward. Because remember, this argument is just a pointer to some region of memory. And so what we interpret those bytes at that address as is entirely up to the kernel module. And so you will have to do some reverse engineering to figure out what is the structure or order of these bytes. Now, one of the things that people asked to do here was let's debug this thing. So before I debug it, I'm going to mention an additional handy GDB plugin, which I'm going to show. You don't necessarily need it, but I think it's cool. It's called ptdump. It is installed on the Dojo. You see that line there below my Jeff, opt ptdump pt.py. It's a cool plugin. If I want to debug, normally you'd say, hey, I need to VM debug. You'll notice that the prompt on the right is inside the VM, prompt on the left is outside the VM. Because I want to use ptdump, I'm going to sudo VM debug. This way, the VM debug command is running as root. So, oh, I'm in the kernel, this is magic, right? And then you type VM map and you're like, all right, cool. There's something. Well, when we think about the kernel, I've claimed that there's like this whole other region of memory that is kernel memory, right? That you just can't see and we haven't seen to date. And you still don't see it with VM map. This is where the ptdump command reveals what's really going on in memory. Okay, so here's what we got with VM map. Here's all of that in the grand scheme of things. When you are in the kernel, you are not restricted to this region of userland. In fact, you're not allowed on a proper kernel to access the region of memory that is userland. I know the kernel's all powerful, except that it isn't. There's a security mechanism that prevents that on modern CPU. So this is all of our user space stuff. Did Jan talk about FizzMap by chance? Okay. When I'm in user land and I touch a address, right? Like I say, show me, examine the giant hex at RSP. An RSP is some memory address. What do we know about that memory address? Is that a real physical memory address? No, it's a lie. All right. Everything in computer science is a lie. It's abstraction all the way down, all the way up, when everything you know is just made up. So it's a virtual memory address. Who is responsible for translating that virtual memory address when you're in user land and get the bytes that actually exist in RAM? The kernel, right? It's a combination of kernel and CPU, but we're going to hand wave it here and just say the kernel, right? We can talk more about that next week.
MMU or something.
Yeah. So this FizzMap, it turns out inside kernel memory, there's a region of memory that directly corresponds to the physical address of your RAM. And so there's a translation from any virtual memory address on the entire computer to somewhere inside of FizzMap. This is physical memory mapped contiguously. All right. If we go all the way down here, for this module, what we really care about is these 3 pages right here. Or not pages, but these 3 sections. This is the location in memory where there are executable code, right? This is actually being executed. Okay. So I want to debug this thing. I just wanted to show that because it's like, whoa, man, the kernel's huge. So I want to debug this thing. I want to think about what's going on with my ioctl. How do I do that? Check out the addresses.
Because there are no samples in the GDB session right now, so you can grab it inside the VM.
Right. So one of the problems debugging the kernel, there's several problems. People ask, hey, where is my x64 syscall table for the kernel? It doesn't exist. Right? Where is the functions that I need to know that I need to call? Doesn't exist. All right. People that have a ton of knowledge about the inner workings of the kernel and kernel exploitation, they know it only because they've done it, and they, generally speaking, don't want to share it because kernel exploitation is a highly valuable skill to have. Right? So there isn't great documentation on how to exploit the kernel or what functions you want to use. Because when something does become, generally speaking, well known as an exploitation path, it just gets fixed. So people that do kernel exploitation don't write giant docs for you to exploit the kernel. But we need to figure out where is ioctl, right? Where is device ioctl? And you may naively be like, okay, well, give me info, func, device, ioctl. And it just says no. Because that kernel module is not a symbol inside the kernel itself. Instead, there is this thing called k-all-syms. If you sudo, you must be sudo. You must do this in practice mode. You must be inside the VM. You will forget this, and this will be what you do wrong. You need to sudo cat proc k-all-syms.
You pipe.
Ah, yes, the pipe. I can do it wrong in a whole new way. What we get is a giant list of functions as well as their memory addresses. We can grep that for ioctl, and we say this is the memory address where device ioctl is loaded. This is valid if you have no KASLR. KASLR is like ASLR just for the kernel. So now I can break at that address. It was a lie. That was a fake GDB prompt. So when you're debugging the kernel, you'll find that GDB can be a bit finicky for a few reasons. One, I didn't do anything there. I just changed my window in tmux, but that signal hit GDB, and now it shows me this prompt, but this prompt isn't really there. Right? Like if I were to say, I don't know, info reg, that's because I didn't actually get a prompt. It displayed it, but GDB isn't really there. I still need to control C and send the sig int. Right? Every time that I change this is when GDB decides that it's going to show me this fake prompt. Okay. So, how do I get there? Why am I not at device ioctl?
Because you didn't call device.
Right. I didn't trigger that code path, so I got to go back inside the VM, find my kernel ioctl, run my, not do.py, we'll do hybrid.py. Give it a minute. Another reason why running C inside of the VM, or not C, but running a compiled binary is probably the way to go. And now I am inside. Give me 200 instructions. All right. That was way too many instructions. But now I am inside device ioctl. And we see there's my copy from user, there's my string compare, there's my copy from user, there's my string compare. All right. You do not want to run the next command or like next instruction. Bad things will happen because the kernel is constantly context switching between a bunch of things. And so you'll end up in crazy places. The only instructions you want to really run when debugging the kernel is SI, breakpoints, and then continue as far as like moving through execution. Because if I were to do NI, let's see what happens. Well, let's see where we are. All right, we should get to 1D8, right? See if we get there. We might. What's up? It's slower than step instruction. Yeah. I don't know, man.
That's what's annoying about this one.
We've gone deep. Well, no, the annoying part about working on kernel stuff is that when you do it wrong, you'll panic the kernel, right? At which point you have to restart the whole VM. Like that can totally happen. So I definitely didn't end up where I wanted to, right? And so step instruction, set breakpoints. All right, I've got 10 minutes. You asked about debugging. What else, like what were you looking for? Those are your high level.
Right. I was just thinking of how to go through like execution, but I guess we talked about SI, basically what commands I could have done. So I guess just SI break and continue.
Yeah, the answer really is SI break and continue. It can definitely be annoying doing SI, and that's where my suggestion would definitely be to do kind of what I was doing over there earlier. Examine, I did 200, which is way too many. We'll say 40 instructions at RIP. Find what I'm interested in, set a breakpoint at the actual address. Right?
That's best practice.
Yeah. Just kernel debugging sucks. That's what it comes down to.
SI still works, right?
What's that?
SI still works.
The statement was SI still works. SI should work. SI? SI works.
99% of the time, though, just like examining instructions and going straight to copy from user is your fastest way to debug. Because that's where all the issues, most of the issues are at. It's like when you're copying like shellcode.
This sounds like a you problem, not a class problem, respectfully, sir.
This was true for previous challenges, like before the SecComp challenge. Like,
So the statement was so somebody found that one of the fastest ways you were setting a breakpoint, I imagine, at like ioctl, and then setting another breakpoint at copy from user,
Yeah.
and then going from there.
Yeah.
And that's a way, right? You can certainly do that. That's still a double breakpoint. In this case, if I didn't know this fact right here, that wouldn't work. I hope people at this point can identify that fact and why that matters. But that's a fair way of thinking about it. Is hopefully this program copies from user, and you could break there, but you don't want to break in copy from user, right? And so if does this work? Let's find out together.
Yes. I think it's
Nope, no
underscore
love.
copy from.
Is that what it is?
I mean, that's what it shows.
I know. Try
Similar.
star.
Okay. No, I'm in underscore copy from user, from inside copy from user, inside. I've gone down this rabbit hole of this is not where I want to be, right? And it had nothing to do, if we look at the stack trace here, and nowhere in here is my like device ioctl, right? I mean, no, this is user land, this is kernel. How do I know this is user land and this is kernel? Right, the address. So if the highest order bit is set, then it's the kernel gets it. All virtual memory is split in half like that. And so the transition from user land to the kernel is not going into this device ioctl, right? And so I do not think I am where I want to be.
I think you just went a few instructions inside the copy from user. You weren't at the
Really? You think I was in the right spot? All right, well, Finney should work. Yeah, we got a Finney again. How many Finneys you want?
seems like you're in the
You-
task.
I think you're wrong. I think we context switched and we're like somewhere completely unrelated. I'd be happy to be proven wrong here though, because it's one of the. If the kernel can resolve all of this, then it clearly is not inside where we were, right? I could Finney all the way until this like goes. We're not going to get where we want. And so that is one of the problems, right? Is you may end up at the function you want, but you can no longer think about things in terms of like linear execution. It's not one thread of execution that's going. I set a breakpoint at a function. That function could be called in 20 different processes, right? All of them are context switching, and you don't know which process called that action to get you to that point in the kernel. And so that's a problem. And so I like having linear execution and setting breakpoints and using SI so that I just don't get lost there. Because once I go free, right, I release the kernel and I'm like, come back whenever you get here. It very rarely does what I want. And so that is a source of trouble. Someone says there's an Easter egg if you panic the kernel 1,000 times. I don't know about this. Okay. What is unique about kernel shellcode? So this doesn't have shellcode, but Jan talked about it a little bit. I got like 5 minutes. Do we have a level here that has some shellcode? 6? Shellcode. All right. Let's see how messy this thing is. Development item. I just need to figure out how to get shellcode into this bad boy. Because what's one of the things that's different, there's some people that said, yeah, level 6, level 7. So clearly some people are trying to do it. What is different about shellcode inside the kernel?
You don't have syscalls.
I'm sorry?
You don't have syscall.
Okay, I don't have syscalls. What can I do instead?
Or you can just call the syscalling method. The method.
Okay, so instead of doing a syscall, you can call the underlying function inside the kernel that triggers that behavior. Now, I would suggest that you don't do that. You can.
What about pointing to an absolute address?
What about pointing to an absolute address?
Like, let's say address I want to jump to, I can move that to register and just click on.
Yeah, you can do that. There was like, what if I, like, hypothetically here, if I'm inside, the VM and then I were to cat proc kall sims, and like one of the commands that I really like, and you can definitely get away with some cheese. But Jan mentions it, so it's fair game, right? Is run command. What if I wanted to call run command? Could I just put this constant value in RAX and then call RAX? The answer is yes. You totally can, right? Now, you'll have a problem. If the last line of my shellcode is call RAX, what's going to happen? Yes. The statement was I need to wrap, right? So another problem that exists when you're executing shellcode inside the kernel is you have to exit clean. When we were in userland, we were like, hey, who cares if it's segfaults? Who cares if it's sig aborts later, right? It doesn't matter. Well, if you lock up and crash the kernel, you're going to crash the VM. And so you want to cleanly return. And suddenly this is an important part of what you're doing. So if I wanted to call a run command, I want to call a run command. It's going to return to me. And then I want to make sure that I return in a sane manner to whatever called me. Now, one of the things that if you just went in here and you went to Google and you said kernel shellcode, right? Because I'm sure someone is doing this. I don't know. Well, you'll probably find something about swap GS register and kernel context, but just trust that the function you're in, it returns, right? So if your shellcode returns, let everything else do what it needs to do. All right. I'm not saying that you can't do any of this crazy stuff. I don't know if this particular link has it, right? We're kind of blindly stumbling in here. But you don't need to do it, is the point. And so if you go down this crazy rabbit hole of stuff that we don't talk about, that is on you, and like you're going to have a lot of problems. Just get your shellcode to return and behave the same way as the kernel module would otherwise. All right, I'm going to run out of time before I can run some shellcode. 6 here, though. What do I got? Is this anything interesting? Device, right. We got a buffer. Okay. We print this buffer. If the length is less than 0, we copy from the buffer into the shellcode, and then we execute it. Okay. That's not that bad, right? So let's see if I can get my do hybrid to do something here. So what do I want to do if I want to execute some shellcode in this guy? What do I need to change? I have my octal. Oh, damn. Okay. Now this?
It's in read mode. It's open in read.
Then you need to set up buffer with the shellcode.
I need what?
A buffer with the shellcode.
My buffer is this.
So you need an URL.
I'm forgetting something. What is it?
Contents are attached to that.
Oh.
Not. Should it be red or leave red? We don't need leave damage.
It's a good question. I don't know. Let's run it and see. That didn't work. Why?
We are not in the
I'm not inside the VM. Okay, so I got open and I got release. Must be string, not bytes. You have to specify in Python that you want this.
Even in C.
What's that?
I think you have to do that even in C. If you're opening, you have to specify.
If you're doing right syscall, then probably don't.
Okay, so now what we saw here was I opened it. We see that the write was triggered. It got 1 byte. I imagine that my ret was that 1 byte. I don't know how big ret is. And then it released. We didn't crash. We didn't get like some crazy error. What if instead I said my buff is hello world? Let's make it a byte string too, so that Python is happy. Do I get the same happy output? Well, that's something. So this is, I don't think, did we lock up? We didn't lock up. Nice. So we just, oops. The kernel is a piece of code that cannot fail. Well, not that it literally cannot fail, but if the kernel fails, your entire computer is just locked up and frozen, right? And so there's a couple ways when crazy stuff happens inside the kernel. There's a couple things that can happen. You can get something like this, which is a kernel oops, and then the kernel will try and roll things back to make sure that we don't explode. Now, as an effect of this, did we get a lot of interesting information and leaks about the kernel? Yes. Keep that in mind for the future. The other thing that can happen, depending upon how the kernel is configured, is it can just completely lock up, at which point you have to restart the VM. But with that, I'm out of time. We'll take a look at some task struct stuff a little bit later, but this should be enough to get you started on like the first half or so. With that, I'll leave you guys. Goodbye, good luck, have fun. See you Thursday.